So our goals for Lunabotics this year are to represent Canada. We're one of only 3 teams going to Lunabotics this year from Canada, which is pretty exciting. We're hopefully going to do very well this year. It's our first year going. It's also going to be a huge learning year. So we're going to learn a lot from the competition and hopefully bring that to future years and use our experience to do even better next year. And if we can do well this year, we're going to do it. We're going to come in first.
The mechanical team has finished up the design, like the AutoCAD design. We've started doing a wood prototype, modeled off of a mini cardboard prototype, which is just a very preliminary design. So the way our design's working is we're using a scraper. It's basically just a shovel that's scraping the top 2 centimeters of the material in the mining area, and we're taking advantage of the fact that they're raking the top 2 centimeters, so it'll be looser, which will be easier to mine and dig. And then it's emptying into a reservoir, which is then being dug out with a chain conveyor, which will bring it up to the height necessary to deposit it. So we'll be storing material in both the shovel and the conveyor in order to be able to carry 10 kilograms back in one load. Since we're using a digging method with the shovel, our tire treads, which are giving us traction, are extremely important, and we'll need to do extensive testing. The current design we're using for the treads is a staggered V-shape, and we've calculated the preferred separation between those staggered treads.
The electrical subteam is broken into 3 main parts: the power system, control system, as well as the computer user interface side. Each of those subteams plays a major role in terms of the overall design of the electrical system. Power team is my main area of interest. What we do is we work on the batteries, the voltage regulation, hooking up all the circuitry and stuff to make sure all the power systems work effectively. So things we've been working on right now are designing a buck converter to reduce our voltage from 24 volts to 12 volts. We've been picking our batteries. We've decided to go with 24 volt lithium polymer ion batteries. We've also been looking at voltage regulation, the charging system, a whole bunch of different power considerations which we had to make in order for the robot to run effectively. The next sub-team we have is control systems team. This is our biggest team, and what we mainly do with control is making sure everything works appropriately. So they started off just doing like some basic work with microcontrollers, working on getting LEDs to turn on, getting lights to flash, getting sound sensors to work. And then what we're doing now is we're moving on to work with better motor controllers and better sensors. So as our parts start to come in for our robot, we've been working on moving the actual motors, getting linear actuators to move, positioning with the motor encoders, like a whole bunch of various control aspects. Parts of the team is also working to design our own motor controllers, as well as, if that doesn't work out, selecting the motor controllers that we will be using on the actual robot. The third and final sub-team is the computer team. What the computer team does is it's responsible for building a user interface that when we're operating the robot from a remote location, we can interact with the computer and send commands to the robot. So what we're going to be doing is we're going to be using a PS3 controller. And what that'll do is that'll relay to the PC, which will relay to a PC on board on the actual robot, which will then bounce to our microcontroller, which will go to our various motor controllers and other extended accessories in order for the robot to move, to be able to pick up dirt, to sense where it is, and all the other parts that we need to do for the robot.